this is going to be a bit of a quick and dirty, well, hopefully quick, video on how to produce a graph from a set of data. So I've got a data table here in Excel. As I've mentioned before, I prefer Excel. And one thing that I'm pretty strict on is this needs to look exactly as I want it to look on the document that I'm submitting, the PDF that I'll be uploading to turnitin.com or handing in. So let's quickly just take a look at that, and I can immediately see that basically it's okay. It has the quantities, it has the symbols, which are in Times New Roman italics, it has the unit symbols, it has the plus minus, so delta t for the uncertainty in time and delta s for the uncertainty in displacement. To be nice, actually, that probably should be displacement. Adjust your width of columns as required. It's got plus minus, it's got the unit, all good. One thing I have noticed, 0, 0 in this particular situation, this is a car on a slope. At time 0, the displacement will be 0, so 0, 0 is a completely valid point. And also, if I look down, I see that this says 2.11 and that says 4.61, where you need to be consistent with your number of decimal places within a given column. So if I go up here, 3 decimal places I'm looking for, so 1, 2, 3. So gives us consistency here, and the same applies here. Okay, come on, you can do it. Okay, spinning reach ball. All right, there we go. How many was it? Was it 2? Was it 1? Sure. Okay. So yes, and the number of decimal places of the precision, if you like, of these measurements should be the same as the precision of the uncertainty, which is valid. Okay, so what do we do from here? Well, the simplest thing to do is to select both sets of data and create a marked scatter graph. There we go. That provides us with a starting point, just a starting point. Next thing to do, very important, is to remember to make this large. Okay, so what can I go from here? Let's make it as large as possible. Because I've only got one data series, or there'll only be one visible data series, I can get rid of that. That gives us a bit more space. Also, I want to put a title. So displacement versus time for a car on a slope. And then I can use the format tools up here. Layout tools, here we go. Title, axis label, horizontal axis label, title below label. So this is time in seconds. Axis title, vertical axis title, and this is displacement in meters. That's a good start. Major grid lines, format grid lines. This is just me. I want a grey grid line with dashes. And the format grid line here, add major grid lines, and then format those grid lines. Again, let's make it grey with dashes. It's useful to have these grid lines just because it's a good visual reference, but you don't want it to take away from the overall graph. So let's get a move on with that. So that's our data series. My personal preference for a data series is that you have a marker style that is a circle with no fill. That's if you've got error bars. If you don't have error bars, or if your error bars are insignificant, then you might want to choose something different, like a small cross. But to be honest with you, I can't think of a situation on a real world graph that you would do in physics that would not have error bars. Okay, so that's our data series. Select that, format data series. Oh yeah, sorry, marker, style, color, black. It's blue rubbish. Black. Now, error bars. Our X error bars and our Y error bars. The X error bars are in time, and to be honest, they are very, 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 very small. So, since the X error bars in time are going to be very small, I would personally completely ignore that. You don't need to include it. However, the Y error bars are quite significant, and they have a fixed value of 0.1 meters on our scale, and I prefer to have a cap so I can see that more clearly. And there you go, that's pretty easy, just checking, double checking. Okay, so we now have error bars on our data points, and now add trend line, and we want a nice linear trend line. Now, because we've put 0, 0 as a point, it nicely goes down to the axis there, so we don't need to worry too much about forecasting it forward, although we could do. Is that too much? No, that's good. It's good to forecast a little bit forward from your last data point, just to make any trends more obvious. And I do want to see the equation, so let's put it there on the chart. Nothing else required? No. That equation is very important. We're going to be using that equation, so let's make it a little bigger. Format, font, wait some more, keep waiting. All right, format font, make it whatever looks good. Yeah, that looks about right. Size 14. Text box, by default this is transparent, but as you can see it's a bit hard, can be a bit hard to see the numbers over the lines, so fill, make that fill white. Okay, anything else? No. But S, the displacement, which technically should be over here, times New Roman, italics, equals 0.4279 t for time plus the intercept of 0.0603 times New Roman italics. There you go, Bob's your proverbial. So having a quick glance, we've got a nice line here which goes through every error bar, which is really good, apart from this point here. So I might want to have a second look at this data. This is one of the reasons why it's good to try and get these graphs as quickly as you can, because if I'm sitting in a room with the equipment in front of me, I can very easily go, you know what, I need to have another look at this particular data point. I can go and I can take it again. Okay, so that's always a good idea. Okay, now, the next stage is I want maximum and minimum gradient lines. The maximum gradient line, you just worry about the first and final point in the series, will go from, given that I only have error bars in the displacement, we'll go from the minimum displacement at time 0 to the maximum displacement at time 4.6, and vice versa. The minimum gradient will go from maximum at time 0 to minimum at time 4.6. So the best way to do that, shove this out of the way a bit so you've got some space. Do a copy paste here. Clear the contents from this because you don't need them. And go. Okay, this is going to be max. And this is going to be min. So the maximum gradient will go from the lowest value of displacement, which is actually minus 0.1. We'll go to, instead of 2, minus 0.1, enter. and we'll go up to the maximum displacement, which will be 2.1. 2.1, enter. And vice versa for the minimum gradients, this will be 0.1, and that will be 1.9. Okay, going back to the graph, you're now basically going to add more data. So select data and add another data series. The x values, which is time, will be the same. Oh, no, from there. Here you go. Select that, then automatically populated there. Click that to feed back in. The y values, there, plot to feed back in. And without even having to press OK, you can see I've got a data point there, a red one, and a data point there. That's grand. That's fantastic. Now let's add another data series, x values again. Just drag and populate. And the y values now for my minimum gradient line. Drag and populate. And again now that green triangle to green triangle. So those are the maximum and minimum gradient line objects. So now let's add the trend lines for that. So you've got to be careful. Make sure your label is pointing to where it needs to be. So that allows you to add a trend line. Options, let's go forward a period. And now let's make this slightly darker and a long dash line. Lovely jubbly. Check. Okay. And oh, that's one other thing here. Format trend line. Add the equation. 4.77. Then do this. Oh, and then make sure you've selected the data point, format data series, marker, style, no marker, and it disappears. So all you're left with is that maximum gradient trend line. Similarly, series 3, add a trend line, options type, yes, options, forecast it forward, display the equation, make it the line, make it the color, change the weight. OK. Go back to the data point. Format data series, marker style, no marker. Move this over here. Now, what I would do right now is the graph is basically now complete. All I need to do is make a record somewhere of these two gradients. So the gradient maximum is 0.4772. Max grad, min grad 0.3905. Okay. Once you've done that, you can actually delete these. You don't need them on your graph. You just needed the information from them. Why is that useful? Well, because the gradient is 0.4279, so but the range in the gradient equals that minus that, which equals that. So that's called range. And the range divided by 2 equals that divided by 2 equals this. So our gradient is 0.4279 plus minus 0.0. Now 0.4335, but we always go to one significant figure and round it up. So 0.05, which is to 2 decimal places. So let's go back here. So well, let's write the whole thing there so you can see the 0.04335. Okay, so 0.04335 is 0.05 rounded, and 2 significant figures is 0.43. So our gradient will be 0.43 plus minus 0.05. One final thing to do, just to illustrate something for you. If Final new blank document. If I was putting this into a lab report, data graph, then this is why I insist that these should be as clearly marked as they possibly can. What happened there? All properly done, because, oh, you can delete these two columns. Well, no, don't delete them, but hide them. If you delete them, the data will disappear. So this is what you want it to look like in the final version. So file, edit, copy, go back to your Word, edit, paste special as a picture, which can then be resized. It can be, done properly. I mean, that doesn't look as good as it could look. Make sure it's big on the screen is my advice, but well, that's up to you. But definitely for the picture, file. I mean, it's optional really for the data table. You could reproduce it, I guess, fairly easily. Copy. But for the graph, it's not so easy. And there, where it really will look good, better to do file, edit, paste special, picture, like that. And then don't forget, make these things, make them large. Oh, I see, hiding the data actually hid those, so you probably shouldn't do that then. Unhide. Yep, that comes back here. But when you're copying the data, you just copy the bits you want. You don't copy the whole thing. Command C. Edit. Paste special. Picture. Ah, yeah, that works better. Okay, and again. Make sure you've got this as big as you can to make it as readable as possible. If you find it's not readable, then go very well. Of course, it'll be better if I look at it more clearly. Okay, looking pretty good. And this is a picture. If you really, really want to, you can do all sorts of special effects, which you don't really have to do. But it looks good like that. Okay, that's my not so short guide to doing those graphs.